All right, y'all, what's going on? In my absence, I'm going to be, this video will be going over 9-3 for you. On here, you will find 9-3 notes, and these are just different formats of the notes. I'll put up a finished copy and the video, as well as email this to you. So if you're seeing this, you should have the email for these notes, okay? I also wanted to point out that this NTI/Logarithm replacement is available. Alright, as you can see, a few people have already did it, actually 4. Alright, so man, please don't hesitate to jump in here. It's due March 10th, but you have unlimited tries to improve your grade right here, okay? Alright, let's get started on these notes. We're looking at the 9-3 notes, the natural base E. Alright, essential question, what is the natural base and how is it used? Alright, your learning objective. Use the number E to write and graph exponential functions representing real-world situations. Solve equations and problems involving E or natural logarithms. Alright, so what is the natural base E? This number right here. This number, this decimal is E. If you put in your calculator E to the first, this is the number you get. Alright, this is called your natural base. Alright. This is its graph. Now, the thing I want to point out is exponential functions with E as the base have the same properties as the functions you have studied. Alright, so everything we did this far. Alright, the graph of f of x equals e to the x is like other graphs of exponential functions such as f of x equals 3 to the x. The domain of f of x equals e to the x is all real numbers, and the range is y equals 0. Might be something you want to know. Now, to kick off right here, we're going to say evaluate f of x equals e to the x with the following values of x, round to the nearest 10th if necessary. So we're going to first evaluate this value right here, e to the second power. So e squared right here, all right, this is e to the second power. You can just punch that in your calculator. So I'm going to press second and then natural log right here. That's how you get your e. And then press 2. So e to the second is going to give us 7 point, say to the nearest 10, so 7.4. Now you would do the exact same thing right here. You'd have e to the 1/2, and you'd punch that in the calculator, and that'll give you 1.6. And then you do e to the -1 as well, okay, and that'll give you 0.4. So again, all you do is just plug these into the calculator and evaluate it. All right, let the calculator work for you. Now, down here, the natural logarithmic function. Actually, before I do that, let me go back. I just want to show you again how to put this in the calculator. Press second, press natural log right here, e, and then I'll do 1/2 again, just so you can see e to the 1/2. And there you go, 1.64, so 1.6, because it says round to the nearest 10th, so 1.6. Now, a logarithm with a base of e is called a natural log, and it's abbreviated as ln, natural log, rather than as log base e, okay? Natural logarithms have the same property as log base 10, and logarithms with other bases. The natural logarithm, f of x equals ln of x, is the inverse of the natural logarithm function f of x equals e to the x. Alright, so y equals log base e of x is written as natural log of x. Alright, so this right here, they're inverses. Y equals e to the x is the inverse of y equals ln of x. Alright, the domain of f of x is ln of x, and x is greater than 0. The range of f of x of natural log of x, or I said ln of x, but natural log of x is all real numbers, okay? And there's just the inverse of this over here. E to the x, the domain is all real numbers. The range is y is greater than 0. But see how this is x is greater than 0 for the domain, and y is all real numbers. They're inverses of each other. So there they go. Now it says evaluate f of x equals natural log of x with the following x values. So this time we're going to do natural log of 2. just press natural log right here of 2. And you get 0.69, so 0.7. I'm going to round to the nearest tenth right there. So 0.7. Uh-oh, this thing is tripping. Alright, and then right here we're going to do the natural log of 1/2. So natural log of 1/2. Or you can punch in 0.5, it doesn't matter. Alright, and we'll hit enter on that and we'll get negative 0.7. Alright, negative 0.7. And I just want to point out, man, these are reciprocals of each other. So see how that was 0.7, that was negative 0.7. Anyway, we got this natural log of negative 1. Natural log of negative 1. And alright, notice I got an error right here, none real answers. Alright, this does not exist. Okay. Does not exist. Alright, and here's the reason why. Just to show you. See the graph right here turns and goes down infinitely. Alright, remember the domain is x is greater than 0. So all the x values are greater than 0. This is an asymptote. The y-axis is an asymptote. Alright, for natural log of x. So that's why negative 1 doesn't exist. This graph will never cross and have an x value of negative 1. So anytime you have a negative value or any value less than 0 for the natural log, you can assume it doesn't exist because it doesn't. Okay. Alright. To introduce this property here, and it's kind of like we did yesterday. These two will always cancel each other out because they're inverses of each other. Alright, that would be like if I had 2 times 1/2. Well, I'll get 1 because they'll cancel out. Alright, well, it's the same thing right here. Natural log and e are inverses. So to simplify this, they'll cancel. And I'm left with 0.15t. Oops, 0.5. Man, I'm sorry. 0.15t. Okay. Now, with this problem right here, this problem is, you got to think back to the rule yesterday where we talked about if you have a log, sorry about that, this power rule from our logarithm. Matter of fact, hold on. Monday, we looked at this rule right here that said that if you have an exponent, alright, for your argument, you could bring the exponent out front. Okay. Well, since we're condensing right here, you got to take the 3 and put it back right here. Okay. Like we did with these examples. Oh, we didn't. No. Oh, yeah, we did. So you got to take the 3 and put it back right here. Alright, as a power again. So that's how I'm going to start this first problem. Excuse me. With this first problem right here, I'm going to put this 3 back as an exponent right here. So I'm going to rewrite it so you can see it. It's going to be e raised to the natural log of x plus 1 raised to the 3rd power. Alright, so e to the natural log of x plus 1 cubed. Again, just move that exponent back to the power position. Now, your e and your natural log, since they're inverses of each other, they will cancel out. And I'm left with x plus 1 cubed. Now, I'm not going to ask you to expand this, alright, because if I did, you'd end up with a polynomial. Alright, I'm not going to ask you to do that right now. I just want you to focus on simplifying natural log and e. Alright. For this one right here, natural log of e to the 2x plus natural log of e to the x. Again, these are inverses, they cancel. And over here, natural log of e cancels. And then you just have 2x plus x, which is 3x. Okay. Now, this next set of problems we got to solve. Alright, we got to solve. Now, I want you to notice right here that The x plus 4 is in the parentheses of the natural log. There's nothing to add. There's nothing to subtract. There's not a number out here, okay? So what I want to do is I'm going to get rid of this natural log. And how do you get rid of that natural log? Well, we just did it. All right. What's the inverse of natural log that we can apply to this problem to get rid of natural log? Well, it's e. All right. We saw that e, if I put this side, I raise that side to the e, and I apply e to this right side, because remember, whatever you do on the left, you have to do on the right. E and the natural log will cancel on the left. And on the right side, you'll have e to the 54th power, okay? Anytime you apply e directly to a value, it becomes an exponent. And then I'm just gonna subtract 4 right here. So x equals e to the 54th power minus 4. And I'm gonna leave it there, because this will actually give you a scientific notation numbers like 2.83 times 10 to like the 23rd power. I'm not gonna ask you to do that right now. Okay. You work it here, and this is fine. Okay, x equals e to the 54 minus 4. All right. This one, okay, this one's a little simpler because it already has e raised to the natural log of x to the 8th. So that is going to cancel right there. So you have x to the 8th equals 65,536. Now, I need to simplify for x. So what I'm going to do is I'm going to raise both sides, because I gotta do something with this 8th. So you could take the 8th root, all right, but I'm going to raise both sides to the 1/8 power. All right, remember that'll cancel, so it's just x to the 1st. And then you can punch this in your calculator. All right, so you can go 65,536. All right, here we go, 65,536 raised to the 1 divided by 8. Or you can take the 8th root if you know how to do it. All right, that's if you raise it to the 1/8. If you want to know how to do the 8th root, press 8, then math, and then come up here to option 5. Then there you go, you have the 8th root, and then you would just put it in. All right, if you get stuck right here, just replay it. You'll see how I did that, but the answer is 4. Okay, x is 4. All right, last part, and we did this yesterday, okay? Find the inverse. You treat this exactly like you would a logarithm, okay? Except instead of converting with b, x, and a, this one you just need to apply e. All right, when you get to the point of no other movement but natural log. And here's what I mean. I have natural log of x minus 4 equals y. Well, again, to find the inverse, we start by switching x and y. And now we're going to solve to isolate y. So I'm going to add 4 on both sides. So you have ln of y equals x plus 4. And now I need to get rid of that y. Excuse me, get rid of the natural log. All right, and how do I do that? Well, I'm going to apply e to both sides of the equations. And remember, this whole side is now applied the e. So that cancels. And right here you have e x raised to the x to the 4th, okay? So that's the exponent now. Remember, when you apply e directly to a side or a value, it all gets raised to the exponent position. So y equals e to the x plus 4. For this one, again, we're going to switch x and y. All right. Now, we want to work to get y by itself, so I'm going to subtract 2 on both sides. Now, you see how natural log, this is a part of the natural log. Y plus 6 is natural log of y plus 6. Well, I'm at the point where I can go ahead and solve this, all right, by converting it or applying e to both sides, all right? So you're going to get that right there. So e to the x minus 2 equals y plus 6. And then our last step here will be to isolate y by subtracting 6 on both sides. So e raised to the x minus 2 minus 6 equals y. This is the inverse right here of 13. E to the x minus 2 minus 6. And our last problem, man, didn't mean to do that. Start by switching x and y. Look at that. I did that mistake right there. You don't want that. You want y. There we go. So we're going to start by adding 3 on both sides. Okay. Now we're going to divide by 2. And next, we're at that point now where we can't move the y minus 5, that 5, because it belongs to the natural log. So we're going to raise both sides. We're going to apply the e to both sides. All right, so you have e raised to the x plus 3 divided by 2. And that's going to equal y minus 5. And then we wrap this up by adding 5 to this side right here. So you have e raised to the x plus 3 over 2 plus 5, and that equals y. And this is your inverse of number 14, okay? So that concludes this lesson, guys, all right? I tried to keep it on 20 minutes, which I did. Watch it again if you need to. We got a quiz on Friday, so I just wanted to make you aware of that, all right? Now, you need to complete this assignment 9293. All right, 20. This isn't right. This is the old version. It's 25 problems now. But complete this 9293 practice. Turn it in on Google. Okay. I will catch you later.